Hi student. So in the last lecture we have seen the n job 2 machine problem. Today also we will see the n job 2 machine problem. So here it is a problem. Determine optimal sequence and elapsed time, idle time of the following 8 jobs on a machine 1 and machine 2 used in the same sequence to process these jobs. So same sequence is nothing but what do you mean by same sequence? So means first performing operation on M1 and then on the M2. In some cases the operation may be given first M2 and M1, but here the sequence is M1 and then next sequence is a M2. So here this sequence is given. Now again we have to solve this problem with for finding out the sequences. So for finding the sequences, so first step is select the smallest processing time on these two machines. So 5 4 22, these times, from this time we have to select the smallest processing time. So here smallest processing time is a 2. So here for job number 7, so you can say job number 7, 2 is the smallest processing time for job number 7. Now this 2 is on machine number 2, so we will place that job here. So from a last in a sequence we will place this job here. So job number J7 we will place here. Okay, then we will cross this job. The next is the next smallest processing time. So now remaining after that 2, 4 is the next smallest processing time. So 4 is at 2 locations. So here it is also 4 and here it is also 4. Now this 4 on machine 1, both the 4s are on machine number 1. So which job we have to take in the first in a sequence? So when machine number 1 we are starting from this end. So this job number 2 is also 4 timing, job number 8 is also 4 timing. So we will put arbitrarily any job as a first job. So suppose I am putting here J2 is a first job, then I will put a J8 job. So it is okay. Or either case you can put a J8 is a first job and J2 is a next job. This is also okay. Both the sequences are okay. So we will solve by these sequences as well as this sequence. So here J7 is already there. Now we will cross this 4. So here cross. Now next smallest processing time is here 5 is there, here it is a 5. So for job number 1 there is a 5. So for job number 1 it is a 5 is the smallest processing time and which is on machine number 1. So we will start from this end, means we will put the job number J1 here. So J1 here. Now we will cross this. Now from remaining 16 15 11 7 8, so here 7 is the smallest processing time. Now 7 which is on a machine number 2 means job number 6 we will put at a last job number 6 here as well as job number 6 here we will put, and then we will cross this. Now from remaining two values 16 and 8 and 15 and 20, so 8 is the smallest time, so which is also on, so this 8 is also on machine number 2. So we will writing from this end. So job number 4 we will write here, on job number 4 we will write here, and we will cross this. Now from remaining 15 20 22 12, so 12 is the smallest processing time, so which is on again machine number 2. So we will write job number 3 here, job number 3 here, and we will cross, and only one job left and one is sequence here, or one box is there. So job number 5 is here, I will write job number 5 is here. Or these are the two sequences possible. We can do the operation in this sequence 2815 or 8215. So both the operation can be possible. So you can calculate the elapsed time and idle time by the both the sequences. So now here I will solve with the first sequence. You can try with the another sequence. You will get the same answer, no issue. So this is a sequence J2 8 1 5 3 4 6 and 7. So I will write the sequence first and will solve the problem. So here I will write the sequence. So first is a J2, then J8, then J1, then J5, then J3, then J4, then next is J6, and next is a J7. So I will once again check 2815. So 2815 3 4 6 7 3 4 6 7. So this is a sequence. I know the sequence. Now then we will write the first. I will separate this by the machine 1 and machine 2. So this part is of for machine 1 or machine A, and this is part for machine 2 or machine B. Now here we will start with the first job number 2. Now in time, or when the job taking on the machine, so in time is a 0. So before that we will write the processing time for this sequence. So for job number 2 the sequence processing time is 4 and 10. So 4 minutes required on machine number 1, 10 minutes on machine number 2. So I will write here suppose 4, and processing time for machine number 2 is a 10. Similarly for job number 8, so for job number 8 4 and 21. So I will write here 4 and 21. Then job number 1 5 and 6. So job number 1 5 and 6. Then job number 5 15 and 20. So here 15 and 20. Job number 3, 22, 12. 22 and 12. Then job number 4, 16 and 8. So 16 and 8. Job number 6, 11 and 7. So 11 and 7. And job number 7, 9 and 2. So 9 and 2. So once again you can check the times. So that will be 4, 4, 5, 15, 22, 16, 11, 9. And here 10, 21. So here 8 number job is 4 and 21. Okay, so here 21, then 6, then 20, then 12, then 8, then 7, then 2. Okay, so here we are starting with the operation. So we will start with the operation when in time for job number 2 is a 0. That is means first time we are taking the job on operation. So it will start at 0, then 4 is the processing time, so out time will be the 4. Similarly, after 4 minutes it will go for a machine number B. So 4 plus 10, that will be the 14. Then second job we are taking after this 4 minutes. So 4 here, so 4 plus 4, 8. So we are going on machine number 2 here after 8 minutes, but for first sequence there is a 14 minutes required. So it will start after 14 minutes, and then 14 plus 21, that is 15, 35 is there. Then job number 1 starts after 8 minutes, and 8 plus 5, 13. So it will go after 13 minutes here, but here 35 minutes required to complete the operation. So we will start with the 35. 35 plus 6, that is 41. Then job number 5 starts at 13 plus 15, that is a 28. So we will go after 28 here, but here completing operation 40 minutes required on machine 2. So we will start with the 41. So 41 plus 20, that is a 51 and 61. Then next here 21, we will start with the 21 plus 22, that is a 50 time. We will go after 50 minutes here, but here completion time is required 61. So we will start with the 61 plus 12, that is 63 and 73. Okay, then here we will start with the 50, because 50 here after the job number 3 we will start with job number 4 with 50 plus 16, that is a 66. So we can go here after 66 minutes, but here this machine is empty after 73 minutes. So we will start with the 73. 73 plus 8, that is a 81. Now for job number 6 we will start with 66 plus 11, that is a 77. And here we will go after 77, but here completion time is 81. So start after 81 minutes. So 81 plus 7, that is a 88. Now here this job will start at 77 plus 9, so that is 86. And here it starts after 88 plus 2, that is a 90. So here in time and out time we have calculated for both the machines. Now we will calculate the idle time for each machine. So here this 90 means completion time, or we can say that is a elapsed time, or total time required to complete the operation is a 90 minutes. So if the case is minute or hour or week, what is in it given. Okay, so now we have to calculate the idle time. So first we will calculate the idle time for a machine number 2 or machine number B. So here 4 minutes, after 4 minutes it started the operation. So first 4 minutes is idle time here. Then here it complete up to the 14. So 14, the next job is started after 14. So we will take this difference here. So 14, 14, 0. Then 35, 35 difference is 0. Then 41, 41 dash. Then 61, 61, 0. 73, 73 dash. 81, 81 dash. 88, 88 dash. So idle time for this machine is a 4 hours or 4 minutes, what is given. So idle time on machine number 2, that is a 4 minutes. Now first we will calculate for a first machine. So it started this operation at 0 minute. So there is no idle time. Then continuously working 0 to 4. So 4 dash, then 4 to 8. It will start with the 8. So here 13, then 28, 28 here, 50, 66 and 77. So continuously this machine is working up to this point. Okay. So there is a no idle time, means machine started operation at 0 hour or 0 minute and completed after 86 minutes. But this is after 86 minutes, it is idle up to the 90 minutes, because 90 minutes is the total time required to complete all the operation, and from 86 to 90 this machine is idle. So 90 minus 86, that is again 4 minutes is idle time for machine number 1. So this is for machine number 1 and machine number 2. So both having a 4 minutes idle time and 90 minutes is a elapsed time. So here I have taken the sequence of J2, 8, 1, 5, 3, 4, 6 and 7. So you can take this sequence and also calculate the elapsed time. You will get the same answer. So in the next lecture we will see the n job 3 machine type of problem.